All right, hello grade 9s. So today I'm posting the solutions to the practice that I posted yesterday. So I didn't post a full lesson because it's all review stuff. So it's a good opportunity for you to sort of see where you're at with this linear relations material, which so far is mostly from last unit. Okay, so the first question says, does each set represent linear or nonlinear? To do that, we find the first differences. Remember, the way these work is you do the bottom number minus the number above, so we get 7 for the first one. 27 minus 8 equals 19. So I can stop already. If any of the first differences are different, then it's non-linear. Okay, so it doesn't matter if the next one was the same and all of them are the same. If there's one pair that's different, it's non-linear. Okay, so now I do this one. So I do 750 minus 450, and I get 3. And then here I do 1050 minus 750, I get 3. 1350 minus 1050, and I get 3. And in this case, all of the first differences are the same. So we can say that this is linear. And you would say the first differences are not the same, the first differences are the same. That would be the explain part. All right, determine the first differences. So from 0 to 800, that's 800. 1600 minus, that's 800 again. This is 800 again. 800 again. And 800 again. The first differences are 800. They represent the distance of, now we look over here and we see how much this is going up by each time. And this is going up by 2 laps. So 800 meters is the distance of 2 laps. Is it linear or nonlinear? It's linear. First differences are all the same. What is the distance of 1 lap? Okay, so to get the distance of 1 lap, we want meters per lap, which is the rate of change. So you probably already figured out that if 2 laps is 800, then 1 lap is 400. And if you didn't, you could have done this. 800 meters divided by 2 laps equals, you divide 800 by 2 and you get 400 meters for 1 lap, or per lap. Determine the rate of change. Okay, so for the rate of change, I'm just going to pick 2 points. I'll pick this point and this point. I mean, you can pick any 2 points at all, it doesn't matter. We do the rise. So here the rise is going to be 9 minus 0. And we find the run. So the run equals 2 minus 0. Notice the run is the x values, the rise was the y values. So we get 9 and 2, so the rate of change is 9 kilometers divided by 2 hours. And if I divide those on the calculator, I get 4.5 kilometers per hour. The rate of change represents the speed. And that's it. Okay, number 4, determine the rate of change. So again, I'm just going to pick these 2 points here. The rise goes from 0 to a height of 1850. So the rise is 1850. And the run goes from 0 to 2. So that's 2. And then the rate of change is going to be $18.50. And I get my units from right here, divided by 2 hours. And if I divide those on a calculator, I get 9.25 per hour. And if it seems like I'm going fast, it's because I wanted you to try it first. Okay, so the idea isn't that you're seeing this for the first time. The idea is that you've tried this. So if you haven't tried it, I really encourage you to stop the video, try it, and come back later. So in this case, what does the rate of change represent? It is the earnings per hour. And if you're not sure, sometimes the title can help. Write an equation. Okay, so we're going to say E equals, instead of Y equals, remember this is Y equals mx plus b. M is my rate of change, which I just found was 9.25. And then instead of x, I'm going to take a letter from time worked in hours, and I'm going to pick h for hours, and then plus the initial value, which is 0. And of course, we don't need the plus 0. Okay, so now for the hard stuff. How much would Jasmine work for working 10 hours, earn for working 10 hours? So we do 925 times 10 plus 0. And if I multiply that, I get $92.50. All right, number 5. A school has t-shirts with the school logo. The cost is $35 setup, and then $6 per shirt. So write an equation for the cost. So it's going to be C equals, now we need our rate of change. We can always find that with the word per, so 6 per shirt. So per shirt, so let's write S for number of shirts, and then plus the initial value, which in this case is the $35 setup fee. All right, now we're asked to use the equation to determine the cost to buy 50 shirts. So we take the equation, and where there's an S, we plug in 50. And then plus 35. 6 times 50 is 300, plus 35 is $335. Use the equation to determine the cost to buy 150 shirts. So C equals 6 times 150 plus 35. All right, so 6 times 150, I believe, is 900 plus 35 is $935. And in the end here it says, look at your answers to parts B and C. When the number of shirts tripled, so 50 to 150 is times 3, did the cost triple? Well, let's see. If we were to have tripled 335, we would have got 1,005. So no. It didn't triple. And why is that? Why didn't it triple? Well, we can say the cost did not triple because of the initial value. We added 35 to both cases, and so simply tripling the number of shirts does not triple the cost. If we didn't have that initial value, if you ignore that plus 35, then we would have had 300 and 900, and it would have tripled. But then when you add 35 to each, it kind of messes with the whole tripling situation. All right, so here we go. Rate of change. All right, so I find 2 nice points. And obviously this is a great nice point here, and this looks like a good point here. So the rise, it goes up to 30 from 0, so that's 30. I'll put the units in just for fun. And the run goes from 0 to 2, so 2 liters. The rate of change is 30 kilometers divided by 2 liters, and that is 15 kilometers per liter. What does the rate of change represent? Well, it's the number of kilometers driven with 1 liter of fuel. So if you had 1 liter of fuel, you could go 15 kilometers. Write the equation. Okay, so my y value, remember these are y equals mx plus b. My y value comes from here. So d equals, now I need my rate of change, which is 15. And for my x value, I'll say L. So 15L, so 15 times the number of liters plus 0. I don't need to write plus 0. On 30 liters of fuel, it would be 15 times 30. And if you had 30 liters of fuel, you could go 450 kilometers. Okay. The graph on the right shows the height of a hot air balloon. What is the balloon's initial height? Well, that's right here. So it's 250, and then for units, I go here, and it's meters. To determine the rate of change, I pick two nice points. Here's a nice one, and here's a nice one. So I'll do the rise here so you can see it. So rise, and we do the y value of the second point, so 230, minus the y value of the first point, and we get negative 20. That negative is important because the hot air balloon is coming down, so its rise is negative, and then the run is 2 minus 0, which equals 2. So the rate of change is negative 20 meters divided by 2 minutes, and that's going to be negative 10 meters per minute. Okay. And now the question here says, what does the rate of change tell you about the movement? And so the 10, tells us the height is changing by 10 meters every minute. The negative sign tells us the height is going down, or the balloon is falling. And really the point of this question was the negative sign. And now for an equation, well, instead of y equals, we're going to have h equals, and then we've got our rate of change, which is negative 10, times the time in minutes, so I'll say t for time, plus the initial value, which was 250. Okay, and now it says use your equation to determine the height of the balloon after 7 minutes. So we sub in 7 for time, and we've got negative 70 plus 250, and I would say that that is 180 meters. And let's check it out here. So 7 minutes, if this kept going, 7 minutes would be about here, and if we go over, that checks out. 180 meters, right? So it would fall again and again, and yeah, that looks about right to me. But we don't need to do the graph because we used an equation. Now for the hard one. Use your equation, so h equals negative 10t plus 250 to determine when. Now determine when, that means find the time. So this means in this case we're going to solve it the hard way, and we need to know what h is. Well, when it hits the ground, what's the height? 0. So we sub in 0 for h, equals negative 10t plus 250. And now we're going to solve for t like we did a few units ago. We got to isolate this term, so we subtract 250 from both sides. So we get negative 250 equals negative 10t. And now, to truly isolate t, we divide by negative 10 on both sides. These cancel. A negative over a negative is positive. 250 divided by 10 is 25. So after 25 minutes, the balloon hits the ground. This is the hardest question so far, and you'll see lots of those coming up. This is a lot of what this unit is about, so make sure you've given that a chance. All right, fill in the blanks below. Direct or partial? Well, it is direct if it starts at 0. Does this start at 0? It does not. So partial. I'm just going to go through and do the direct or partials. Does this start at 0? No. Does this start at 0? Yes. Does this start at 0? It does. This one does not. And this one does. All right, so there's the direct or partial. The y-intercept, that's the same as the initial value. So this one's 40. This one looks like 35. This one's direct, so it's 0. Remember, y-intercept and initial value mean the same thing. Direct, so it's 0. Direct, so it's 0. And then this one, 15. That looks like, I'm going to call that 12. Okay? All right, let's go back up. Now we'll do the rate of change. So the rate of change for each one, we need a rise and a run. So the run here is 2. The rise, well, it's going down, so it's going to be negative 40 to 30 is 10. So negative 10 is the rise, over 2 is the run, which is negative 5. Next one, we'll go from here, and I'll find this is a nice point here. And if you use different points and your answer is a little bit different, that's fine. So the rise goes from 35 to 75, so that's a rise of 40 and a run of 10. So I get 40 over 10 equals 4, and I'm going to say dollars per membership. And over here, this is going to be negative 5 meters per minute. The y-intercept, we can say it's 40 meters, $35, 0 meters, $0. I'm just giving units to everything. And now we'll go through and finish the rates of change. All right, so here we go. We got 2 nice points here and here. Remember, you always want nice points. Really ugly line there. The rise goes from 0 to 2,000. The run goes from 0 to 5. So 2,000 divided by 5 is going to be 400 meters per lap. Next one. The rate of change, I picked 2 nice points if I can find them. So I got this one, obviously. Now let's pick this one. All right, so let's see here. The run is easy, that's 8. The rise starts at 0. It looks like it goes halfway between 90 and 100. I'm going to call that 95. So 95 divided by 8. 11 point, let's say around 11.9 dollars per hour. So about 11.90, I guess. Or we could have done 11.88. And if your answer is slightly different, maybe you called this 96. 96 divided by 8 would be 12, and that would be a much nicer answer. Okay, so for me, given the numbers I use, and again, you're doing your best here, so if you got the same answer as me or a slightly different answer, there's a good chance that you will get full marks for that anyway. So I'm going to say this is 11.88, $11.88 per hour. Next one. So let's pick this point, which we said was 12. And let's pick this point. That looks to me like 25. So the rise is 25 minus 12, which is 13. And the run is just 10. So the rate of change is 13 over 10, which equals 1.3 meters per second. And next one, we'll pick 2 nice points. Let's pick these 2 here. So the rise is 50, and the run is 50. So 50 over 50 equals 1 centimeter per centimeter. That's weird. So if you look at this, it's like your height versus your arm span, and you might have heard that they're basically the same. So this kind of confirms that your height goes up by 1 centimeter every time your arm span goes up by 1 centimeter. Okay, number 9. Does each situation represent direct or partial? Explain how you know. So if there's an initial cost, it's partial. A car rental agency charges $23 per day, partial. Michael is paid $30 per evening plus, okay, partial. It doesn't start as 0 is what you would write. The cost for ordering mugs with a custom design is $50 plus, partial. None of these starts at 0. They're all partial variation. So don't feel like when I give a question like this that one of them's got to be direct, because it might not be. Okay, number 10. A company that makes sports trophies and plaques charges $15 for a plaque, So that is your initial fee plus 10 cents per letter. Okay? Complete a table up to 100 letters. Okay, so if you're going to fill this up to 100, let's try going up by ones. 1, 2, 3, 4. Obviously not. Let's do tens. 10, 20, 30, 40, 50. Nope. Let's try 20, 40, 60, 80. There we go. So 20, 40, 60, 80, 100. And now the tricky part. If it's 10 cents per letter and we've got 20 letters, then it's 20 times 10 cents. So it's going to be $2 for these letters. So some of you are going to do this. So this means that with no letters, it's 15 bucks. And then with 20 letters, you pay $2. So this suggests that you pay less for more. Now, hopefully you found out what my error was. And the error is that the letters cost an extra $2, but we start at 15. So this is 17. So it goes up by 2. And then we would do 40 times 10 cents is $4 plus the initial 15 is 19. Again, it goes up by 2. And hopefully now you can see the pattern is this. Okay? Now, graph cost. So cost is going to go up the side against number of letters. And we're going to do it up to 100. So we'll go 0, 10, 20, 30, 40, 50. That's going to work, I think. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now, in terms of the cost, what is the lowest cost? Well, the lowest cost is 15. So we should break the axis here, like so, and then we'll start at 15. And then we can go up, let's see, 16, 17, 18, 19, 20, 21, 22, 23, 24. Good enough. So 16, 17, 18, 19, 20, 21, 22, 23, 24, and then 25 will be way up here. Now what you might have wanted to do was to do the x-axis up to 200 and the y-axis up to 50, because then it gives you more space, right? If you go beyond 100 letters, you might want to know what that's going to look like. Now we plot our points. 0 and 15, that's the initial value. 20 and 17. 40 and 19. 60 and 21. 80, 23, and 125. That'll be basically right there. And now with a ruler, or my digital equivalent, I draw the line, and there we have it. And the question is this direct or partial? Hopefully by now you know it's partial, because it does not start at 0, it starts at 15. Okay, now we're asked for an equation. So it's going to be C equals for cost. Now the rate of change was given to us. It's 10 cents per, and whenever we see that per, we think of the rate of change, and it's per letter. So let's do N for number of letters, plus 15 is the initial cost. Okay, and that's what we were asked for, C and N, so I use the correct letters. Moving on. All right, the table shows the cost for sea kayaking. How much would it cost to take each number? So the first thing I want to tell you is this is X, this is Y. When a table's on its side like this is how it works. I just did this to save space. It takes up a lot less space. Okay, so how much would it cost to take each number of lessons? Okay, so we have all the even numbers and we're asked for odd numbers. So let's check this out. This is plus 58, and this is plus 2. So what I would like to know is if I only went up by 1, what would I go up by here? And so if I'm going up 58 for 2, I can find my rate of change. 58 divided by 2 is 29. So this is going to be plus 29. And then for one lesson, it's going to be $29. And if we're looking for 3, we go from 58 and we go up by 29. So 58 plus 29 is going to be 87. Okay, so $87. The other thing we could do is we could make an equation. C equals the rate of change is 29 times the number of lessons plus the initial value, which is 0. So really, C is just 29 times the number of lessons. And now what we can do is we could do 29 times 3 and get 87. And then part B is for 7 lessons, 29 times 7. $203, and that's it. $203. How did you find out? Used table of values to find rate of change, and then equation. Okay, so I think we're almost done. Calculate the rate of change. All right, here we go. The rate of change, find 2 nice points. The rise is 4 kilometers from 0 to 4, and the run is 0.5 hours from 0.5. So the rate of change is 4 kilometers divided by 0.5 hours. And if you divide them, you might think the answer is 2, but it's 4 divided by 2 that gives 2. So you're wondering, how many times does a half fit into 4? The answer is actually 8. And your calculator can do that if that's confusing for you. And now the next one, the rise is 10 kilometers. The run is 0.5 hours. So 10 kilometers divided by 0.5 hours equals 20 kilometers per hour. Okay. For each graph, write an equation. Okay, so for graph 1, it's going to be distance equals 8. Oh, they want a little d. If you read the question here, it says little d. So distance equals 8t plus 0. And then for this one, it's going to be d equals 20t plus 0. And you might remember that the plus zeros do not matter. So how far has each person traveled after 1.75 hours? Well, for the first one, it's 8 times 1.75. 8 times 1.75. 14 kilometers. And for this one, it's 20 times 1.75. I'm just plugging in. Nothing fancy there. 20 times 1.75. 35. And now for the hard question. How long does it take each person to travel 10? So now what we're going to do is we're going to take our original equations and we're going to plug in 10 for d. And then to solve that, we divide by 8 on both sides. So 10 divided by 8. It takes 1.25 hours to travel 10 kilometers. And then here, 10 equals 20t. We divide by 20 to get t by itself. And we get t equals half an hour. Okay. One graph models a person training for a bike trip, and the other a person training for a marathon. Is Tanya, so Tanya's this one, 8 kilometers an hour. The other one is 20. So is Tanya the biker or the runner? Well, Tanya is the runner. She must be, because nobody's running 20 kilometers an hour consistently. Tanya is the runner because she is likely, hopefully, slower than the cyclist. And hopefully that makes sense. That's it. If we were in class, we would do a fun game. Sadly, we're not. All right, folks, that is it. What I'm going to do for tomorrow, I'm going to post just a little sort of online assignment just to make sure everyone's ready to go. In this unit, there isn't a ton of brand new stuff. So we're here, we did 5.3, and then we got some other problem solving and stuff like that. It's a very short unit. You might remember our last unit was really, really long. Well, this one's quite short. It's just kind of reinforcing and reviewing the last unit with a couple of little extra things. So I know it's been a bit of a slow start, but there are a number of people who haven't submitted or done anything or communicated in weeks. So I'm just really hoping people get back into this, because I think if you don't, grade 10 math will be really, really difficult. All right, folks, reach out if you need help. I'm happy to set up a Google Meet and give you a hand whenever you like. All right, thank you.